In this tutorial, we're going to take a look at families of quadratic functions and through 4 different examples. In the first one here, it says you're asked to find another quadratic function with the same vertex as f of x equals negative 2x minus 3 squared plus 5. So this is in vertex form right now. So the vertex would be at 3, 5. Remember, vertex form looks like this, right at above here. So it's often written like this: y equals a x minus h squared plus k. Now it's a plus k, so this is the y-coordinate. No sign change is needed for the y-coordinate, but it's x minus h, not x plus h, so that's why if it's x minus 3 squared, then 3 is the x-coordinate of the vertex. So the vertex is at 3, 5. So here's my parabola here at over 3, up 5. The a value is negative 2, so if I were to graph this, remember the step pattern looks like this. It goes, it goes 1, 3, 5. And when we multiply that by the a value is negative 2, then this would be negative 2 down 2. 3 times negative 2 is negative 6. And I think that's off the page probably, but that would be negative 10. So if I'm graphing this from my vertex, remember you go over 1 and down 2. The lines are really light on the graph paper here, but over 1, down 2, and then over another 1, it would be down 6 here. So that's how we could graph this function. Now, the reason these are called parabolas or quadratic functions in the same family is because they all have the same vertex. So we're going to look at, I'm going to give 2 more examples, not just one here. So we can make any other parabola up that has a vertex of 3, 5. So I'm going to use vertex form because it's in vertex form. So examples of other parabolas with the same vertex would be, for example, I'll call g of x x minus 3 squared plus 5. So that's the simplest one pretty much because a is 1. So the vertex would be at 3, 5 and it would open up. So the vertex would be right here. And if I wanted, now this would use the step pattern just 1, 3, 5. So if I went over 1, up 1 on either side, same here, over 1, up 1, and then if I did the same thing over 1, remember that's my vertex, over 1 and up 3, 1, 2, 3 there, and the same thing on this side. And then I could draw, you can see the parabola is starting to form here. So basically it would look like that. So that's belonging to the same family because it has the same vertex and axis of symmetry too. Another example would be h of x equals negative 4, and again x minus 3 squared plus 5, so the vertex is still at 3, 5. So this would have, the vertex would be here. If we multiply the 1, 3, 5 by, I see a is negative 4 in this case, then it's a very steep parabola. So it will go down 4 when you go over 1 to the right or left. And then negative 4 times 3 is negative 12. Well, and then it'd be negative 20. I can't show that because it's off the bottom of the screen here. But we could start. And so over 1 and down 4. I guess that would be around there on either side, something like that. And I can't even do the down 12 because it's too far. So that's what it's going to look like. So that's what that parabola would look like. So there's 3 different parabolas that all have the same vertex. So they are said to belong to the same family because they have that characteristic in common. And this tutorial is about just several different kinds of questions that you could be asked to solve around quadratic functions. So this one, you're asked to find the quadratic function that has zeros at negative 2 and 5. So it goes through the x-axis at negative 2 and 5. So I've drawn it here. And pass it through the point 1, 24. So if we go over 1 and up 24, so there's the point on the graph. Almost looks like it's slightly off, but that's probably the limitations of my graphing program I'm using here. So that's basically what it looks like. So this function, now because we're given the roots, it would be easiest to use the root or intercept form. I wouldn't bother use the vertex form here. It'd be, and we could still do it, but it's just not as convenient because of the fact that we're actually given the roots. So remember, the root form looks like this, and of course you can use f of x or y equals a, x minus r, x minus s. The r and the s are the roots, and so we would fill in the negative 2 and 5 in place of the r and the s. And that would look like this. So r is negative 2, so a lot of people don't bother this step and just write x plus 2, but I just want to show that's why the number changes, the sign changes, because the r number is actually negative 2, so x subtract negative 2 is x plus 2. So we'll write that as x plus 2, and of course this is just x minus the 5. And the only other thing we have to do here is find the a value, the stretch number. We can certainly tell, since the parabola opens downward, that a should be negative, but we can't tell specifically what it is from the graph. If you have a graph very accurately, there is a way to do that, but that's not what we're looking at in this particular example. So the f of x or y value of this point that we know on the parabola is 24 when x is 1. So we have this point on the parabola. So I'm going to fill 24 in place of the function value and the 1 in place of x here and here. And then we can solve for a. We can find the stretch number. So this would be 3, this would be negative 4. And so 3 times negative 4 is negative 12. So this would be negative 12a over here equals 24. And I want to isolate or solve for a, so I will divide out the negative 12. And so those divide out. And 24 divided by negative 12 is negative 2. So that's the a value, the stretch factor. So then my equation looks like this, except I now know that this is negative 2. So that's what my equation will look like. So if you have the roots and some other point in the graph, you can use the root form and sub in the y and x values from the point to find the a and then find the equation. You can't use the roots though. See, we need the 124 point. I want to show you one thing here before we go over the other example. So, this point over here is at 5, 0. So instead of using the 124 point that was up here, if I tried to use that point, so this is what would happen. So I would put my my 0 in here, and my 5 in here, and my 5 in here. 0. Now, that kind of looks like I'm putting 0 in place of x. This whole thing is 0, because the f of x is y. So then I'd have this equation, 0 equals a times, and you see this would be 7. And this is 0, unfortunately. So the problem over here is that a times 7 times 0 is just 0, and I get this somewhat true statement, 0 equals 0, but that 0 got rid of my a, so I can't solve for a. So you can't use those intercepts, the coordinates from the intercepts. You need an other point. You could know the vertex too, that would work, but you need any other point except for where one of the two roots are. Example number 3 on the third page, the Golden Gate Bridge in California has a span distance, and these are the two towers. So we sort of see a cross-sectional view of the bridge here. This would be the road here. Here's the towers, and this is the cross-sectional parabolic cables that span between the two towers. The distance between them is 1,280 meters, and the towers are 150 meters tall. Okay, so we're given that information, and so here's our parabola right here. And we're asked to find the equation for that parabolic cable, height between the towers, and then we're asked this question, how high it is at a certain place. So I'm going to draw an axis around this. So I'm going to make that my y-axis. So that's y. This is x. Now I'm calling it f for f of x. You could put y there if you wanted to. So this is my x-axis down here. And we're told it's 1,280 meters between the towers. So if I'm orienting my vertex to be at the origin, then this would be 640 in this direction, and that would be 640 in that direction, which is negative. The distance between negative 640 and positive 640 is the 1,280. Now, if you really wanted to, I guess you could draw your axis here, like this, and have the y-axis right on one of the towers, and then this would be 0 and this would be 1,280. I'm doing this because it makes that vertex form fairly easy, very simple to work with. That's why I'm choosing to put my vertex right at the origin here. So, and we're told that these are 152 meters high. So I put this little dotted line across here so you can tell that that's 152 on the y-axis, or f of x axis. So here's my vertex form. This is the general vertex form, like I wrote on the second previous page, the first page. And the vertex, the way I drew my axes, is at 0, 0. So that's 0 and that's 0. So then this just simplifies to ax squared. So it's a very simple vertex form. So I want to find the a value, very similar to what we did in the second example. So I need a point on the graph. And so I could take any point that I know. 0, 0 isn't helpful, because if I put 0 here and 0 here, then I get that 0 equals 0 again, and I can't solve for a because the a would disappear. So we're told that this point here, you see, is 640 to the right and 152 up. So we could call that point right there 640, 152. Now if you want to use this one, we could call that negative 640, 152, and that would be just as fine. We use one of them. So I'm going to substitute this as my function value, and the 640 is the x coordinate, so I'm going to put it in place of x here. So that's what it looks like. Now I could square this, I suppose, but I'm just isolating for a, so I'm going to divide out both sides the 640 squared. And so those divide out, maybe we'll get the pen going here, those divide out. And so that's what a equals, 152 over 640 squared. And I think it's time for the calculator here. Let's bring that in. So if we divide 152 by 640 squared, and you probably want to be careful how you do that in your calculator, because some calculators might even be squaring the whole 152 over 640. So be careful of how you're doing that. Make sure you know how to use your calculator. Now this is in scientific notation. So that 3.7109375 e negative 4 means 3.71 etc. times 10 to the power negative 4. So I'm going to write this as a normal decimal number. That negative 4 means to take that decimal and move it 4 places in this direction. So if I move it to there, that's 1 place, and then I need 3 zeros before I get to the decimal. So that number would look like this. So it'd be 0.0037. So again, there's the calculator back again. So there's the 37. So the decimal was here. So 1, 2, 3, 4 places. So that's my a value. That's the stretch number. Very, very small. So this is my equation then. I'll substitute that in place of a here. So f of x, or y if you want to call it, equals 0.00037 x squared. Now in B, we're asked, how high is the cable 100 meters from one of the towers? So 100 meters from here, how high is it? Or on this side, it should be the same. And keep in mind that this is not drawn to scale. Okay, so you know, this is 640, that's 152. They kind of look like about the same thing on this. So it's not drawn to scale. But basically, this is what it looks like. So here's my equation. And what I'm going to do, see, 100 meters to this side, so that point there would be 540. So what I'm trying to do is at that place find out how high is the function, how high is the parabola. So really at that point it's kind of like this. Let's get the pen going here again. So we're trying to find for this point, the x coordinate is 540, and we're trying to find how high it is, trying to find the y coordinate. That's what the unknown is here. So we're really just trying to find f of 540. So f of 540 would be 0.00037 times 540 squared. So let's bring the calculator back again. 0.00037 times 540 squared. So 107.892. So about 107.9. About that. So 100 meters from one of the towers, it's about 108 meters high. And actually that doesn't look too off here really, because okay, that's 152, so you know it's a little bit past halfway. This kind of looks like it's getting close to 100, so you could kind of approximate that from the graph reasonably accurately. One more example on the fourth page. And in this fourth one here, the graph shows the profit for a company that produces snowboards. And it says find an equation that models the profit depending on production. Now we don't have a table here, but we could actually make a table of these. I'm going to show how to do that with the graphing calculator after we get the algebra done. So it says let P of X be the profit in thousands. So that's why the thousands is here. This is the profit in thousands. For X 100, this is in hundreds of snowboards produced. So keep in mind that that doesn't mean 5, it means 500. That 20 means 20,000. So I could draw a parabola in. It would look something like that. I'm just freehanding it, so it's approximate. Maybe someone else will draw it slightly different, but you can tell from this the vertex is around 540, something like that. Maybe someone else draw different. Maybe they have it like 640, but it's pretty close to 540. So again, I'm approximating. Now here's my vertex form. And I need a point. Like previous examples, in order to find that A value, I need a point on the graph. So I could, for example, go over here. I'm going over to 7.5 and up to the graph here. It looks like that's around 25. See, each of these is 5, 10, 15, 20. So this is the point I'm using right here. I'm not pointing at that one. At 7.5, it's about 25 high. So I'm going to use that point to substitute in to find my A value. If you choose a different point, you might get a very slightly different A value. It shouldn't be too far different though. So substituting in the 25 here for the profit, and X is 7.5. So 7.5 minus 5 is 2.5. We're going to square. And if you square 2.5, you get 6.25. So this would be 6.25A here. And I'm trying to isolate for A. So the next thing I want to do is isolate this 6.25A term. So I would move the 40 over or subtract 40 from both sides. 25 minus 40 is negative 15 equals the 6.25A. And then to isolate for A, we would want to divide out the 6.25, which looks like that. So those divide out. So A is negative 15 divided by the 6.25. So that's my A value, negative 2.4. So then I can write my formula. So here's my equation here. I need to find the A value. So negative 2.4 is going to go there in place of A. So there's my formula. Now I do want to show, if you have some technology, you can actually do this. I'm going to show how to do this with the graphing calculator. So I want to go into edit here and add my list. So this point here would be the point. Actually, maybe what I'll do, I'm going to write them all on here, what I'm using. That'll be clearer, I think. So this point here is, whoops, we won't worry about that yet. This point here is 0, negative 20. This point here is about 1, maybe negative 4. It's not quite down to negative 5. This point here looks like it's about 2.5, maybe. So see, that would be 15. So maybe that's about 18,000. So 18. This point here is about, it's not quite at 4.5. So maybe we'll call that 4.4, comma, and pretty close to 35. And then this is pretty close to, well, it's pretty close to 640. And then this one here is 7.5, comma, maybe about 23, a little under 25. And this one down here is about 10, comma, negative maybe 18. It's not quite down to the negative 20. So those are the points I'm going to use. So let's bring the calculator back. So I want to type in all those points. So I'm going to X coordinates first. So 0, and then 1, and then 2.5. And so the next 4.4 is the next one. and then 6, and then 7.5, and the last one's 10. Let's double check here. 1, 2, 3, 4, 5, 6, 7 points. Yes, that's right. Okay, so let's go up to the top list. So now all the y coordinates, so negative 20, negative 4 for that one. Should be checking, make sure I'm typing these in correctly. 18 for the 2.5, and then 35 for the 4.4, sorry. And then 640, so that would be 40, 23, and then negative 18 for the last one, negative 18. There we go, that's all my data. So it's in list 1 and list 2, so if you have the graphing calculator accessible, we're to calculate, and the regression model I want certainly would be the quadratic one, because this really looks like a parabola. So quadratic regression, I'll tell the calculator the numbers are in list 1, comma, list 2, and so here it performs the regression. So this is the A value, it's about negative 2.3, so that's pretty close to negative 2.4 we got. Pretty close. So that's the B value, about 23.4, and that's the C value, about negative 23. So to compare that with this graph, I would want to expand this. So then you saw the one translation come there where I was expanding out. So I'll bring this back in a moment. So if we square the x minus 5, we get x squared minus 10x plus 25, and then I'll multiply the negative 2.4 in. So negative 2.4 times x squared would be that term. Negative 2.4 times negative 10x would be 24x. And negative 2.4 times the 25 would be negative 60 plus 40. And so we get this. So there's the A and B and C value. And so we can compare that. 23.4, 24, that's pretty close. This is negative 23 for the C value. We had negative 20. So it's pretty close, even just eyeballing it from the graph. So that's a way you could, get the, through a little different method using some technology, get the regression equation for that parabola. And that's the end of the tutorial.